For problem 2923, we have a circular loop wire with a radius of 0.03 meters and a resistance of 0.39 ohms. At time equals 0, the magnetic field equals 0. The question is asking, what is the current in the loop magnitude at the instant when the magnetic field equals 1.01 Tesla? So first, to find the current in the loop when the magnetic field is 1.01 Tesla, we use the equation V equals EMF minus I, and in our case I equals 0, so this reduces to V equals EMF. We then get the equation V equals IR, and then we rearrange it to find I, so that means I equals V over R. And because of what we proved up here, V equals EMF, we can substitute V for EMF. So I equals EMF over R. To find I, we need to find we need to find EMF. In Faraday's law, EMF equals negative N d flux over dt. And we know that the flux equals B times A, so we plug this in to this equation right here, our flux, and all of that reduces to A equals dB over dt. We then derive it and we get EMF, your number, times T squared. We know the magnitude, or the magnetic field rather, at a given time, so we set it up as BT equals a number times T cubed, and solve for it, which gives us your time, and we plug that into your time, you plug that into here, your T squared, and you get your EMF value in volts. Now we can find I by plugging them into I equals EMF over R, and that'll give you your answer. And B is asking, what is the direction of the current in the loop? It's opposite to the magnetic field, so the induced is coming out of the page, so that would mean that it is counterclockwise.